Review for polynomial functions. It's given that f of x equals 3x to the fourth power plus ax to the third power plus bx squared minus 7x minus 4, where a, b are real numbers. Given that x minus 1 is a factor of f of x, this means f of 1 equals 0 or remainder equals 0. When function is divided by x plus 2, the remainder is 6. X plus 2 equals 0, x equals negative 2, which means f of negative 2 equals 6. Since this 1 is a small number, we can do the substitution to figure out the relationship between a and b. F of 1 equals 3 times 1 to the fourth power plus a times 1 to the third power plus b times 1 squared minus 7 times 1 minus 4. 0 equals 3 plus a plus b minus 7 minus 4. Combine like terms, a plus b minus 8. For f of negative 2 equals 6, you can use a substitution method to figure out the relationship between a and b. But in this video, let me show you the synthetic division. Negative 2, 3, a, b, negative 7, negative 4. 3 drop down. Negative 2 times 3, negative 6, a minus 6. Multiplication, negative 2a plus 12. Adding b minus 2a plus 12. Times negative 2, negative 2b plus 4a minus 24. Negative 2b plus 4a minus 31. Times negative 2 again. 4b minus 8a plus 62. Then adding 4b minus 8a plus 58 equals 6. Since this is a calculator based, you don't have to simplify this equation. 0 equals a plus b minus 8. 4b minus 8a plus 58 equals 6. Go to calculator. Menu. Algebra 7. Enter. 2 equations. Delete xy. Change into a, comma, b. Enter. 0 equals a plus b minus 8. Second equation, 4b minus 8a plus 58 equals 6. Enter. A equals 7, b equals 1. By JDC, a equals 7, b equals 1. Let's go to B. Find the sum and the product of all the roots of f of x. This is the formula for this question. From this function, we do know a sub n equals 3. A sub n minus 1 equals 7. A sub 0 equals negative 4. So, sum is negative 7 over 3. product equals -1 to the 4th power. A sub 0 is -4 over 3 equals -4 over 3. Let's go to C. Factorize f of x into a product of linear factors. Since we already know this function, let's go to calculator. We will put the function into f1 of x. Then enter. For this graph, you need to figure out what's going on here. This is from -10 to 10. Each of these is 1. So we can set up from -2 to 2. Go to menu, 4, window setting, -2 to 2, 1. Since we are only interested in the roots or x-intercepts, for y minimum, let's put -1. Y maximum, put 1. Auto, let's do 0.5. Then enter. It's a little bit clear here. We know 1 is the solution. Let's work out this part more. Still, go to menu, 4, window setting, y minimum, -0.5, maximum 0.5, scale is 0.5. Here it's bouncing back, which means we have x minus this root square. This time, go to menu, 6, 0. Menu again, 6, enter. -1 is the root. Highlight, control variable. Let's go to P, then enter. Go back to this scratch pad, put a variable. We have a P, enter, enter. Then menu, 2, enter. We got a fraction. We know x1 equals 1. x2 equals -4 over 3. x3 equals -1. x4 equals -1 because graph bouncing back. Therefore, f of x equals x minus 1. For this, 3x plus 4, x plus 1 squared. Let's go to D. Using your graph, state the range of values of C, for which f of x equals C has exactly 2 distinct real roots. Let's check the graph of f of x. This is the graph of f of x. Let's sketch this f of x. We need to figure out these 2 local minimum points and 1 maximum point. Let's label x1, y1, x2, y2, and x3, y3. When this is C greater than y2 or C greater than y3 less than y1, f of x equals C has exactly two distinct real roots because the intersection of y equals f of x and y equals c have two intersections. We need to figure out this y1, y2, and y3 first. This is local minimum point, local maximum point. We know this y2 equals 0. Let's go to this y1. So menu 6, minimum point, negative 0.0366 as a 366. For y3, we need to change this window. Go to menu 4, enter. We only need to change y minimum, negative 30. Let's change into 3, enter. It's an ugly window, but we can figure out this minimum point using this window. So menu 6, 2. Negative 6.20. After we figure out this y1, y2, y3, we can write down the solutions. When c greater than 0 or when c greater than negative 6.20, less than negative 0.0366, there are two distinct real roots.